Jupiter's auroras could light up an entire planet, while Saturn's rings rain down icy particles shaped by mysterious forces. This isn't just space. It's a dynamic playground of jaw-dropping weather. Discover how the solar winds shape these celestial wonders and redefine what we thought we knew about our cosmic neighborhood. Space weather refers to the conditions in space caused by the sun's activity. Its constant streams of solar wind, sudden solar flares, and colossal coronal mass ejections, or CMEs. These phenomena can trigger magnetic storms that ripple through the solar system, interacting with planets, moons, and even rings. The Sun, a 4.6 billion-year-old powerhouse, produces these dramatic events through its magnetic field. Deep within its core, nuclear fusion generates immense energy, creating turbulent flows that twist and tangle its magnetic lines. When these lines snap, they release bursts of energy powerful enough to eject over 1.3 million Earth's worth of material in a single event. From this chaos emerges a beautiful order. The sun's energy drives weather systems across the solar system, from Jupiter's mesmerizing auroras to Saturn's mysterious spokes in its rings. Each planet tells a unique story of how it interacts with our star's ferocious power. But what happens when these storms reach our celestial neighbors? How do Jupiter and Saturn, giants of the solar system, weather these cosmic tempests? And what secrets do they reveal about the sun's reach? If you're ready to uncover the breathtaking phenomena of space weather and its dazzling effects across the solar system, stay tuned. And don't forget to like this video, subscribe for more cosmic wonders, and let us know in the comments, what fascinates you most about our sun's power? Can you imagine a light show 1,000 times more powerful than the northern lights? Welcome to Jupiter, the king of space weather, where auroras larger than Earth itself dance endlessly across its poles. These mesmerizing displays aren't just beautiful. They're a testament to the incredible forces at play in the largest magnetosphere in the solar system. But what makes Jupiter's auroras so much more intense than Earth's? And how does a fiery moon like Io contribute to this cosmic spectacle? Jupiter's magnetosphere is a giant among giants, stretching millions of kilometers into space and dwarfing even the sun's influence in its vicinity. When the sun's solar winds, a stream of charged particles, collide with this magnetic powerhouse, they trigger a cascade of reactions. The charged particles spiral along Jupiter's magnetic field lines, crashing into its upper atmosphere and creating stunning bursts of light at the poles. Unlike Earth's auroras, which flare up during geomagnetic storms, Jupiter's auroras are constant, powered by the relentless interaction between its magnetosphere, the solar wind, and its moons. One moon, in particular, plays a starring role in this phenomenon. Io. This volcanic moon is the most geologically active body in the solar system, spewing out massive amounts of sulfur and other charged particles into space. These particles are captured by Jupiter's T2 magnetic field, forming an electrified plasma torus around the planet. As the particles accelerate and interact with Jupiter's atmosphere, they supercharge its auroras, making them not just brighter, but also vastly more energetic than Earth's. These auroras are more than a visual wonder. They're a window into the dynamic relationship between Jupiter, its moons, and the Sun. The light show at Jupiter's poles can release energy equivalent to 1,000,000 gigawatts, enough to power human civilization many times over. It's a phenomenon so grand that even the Hubble Space Telescope can capture its brilliance from millions of miles away. So, next time you think of auroras, imagine Jupiter's, a celestial masterpiece that outshines anything we've ever seen on Earth. And as we marvel at this cosmic dance, don't forget to share your thoughts in the comments below. What would it feel like to stand beneath such a spectacular light show? Stay tuned as we journey next to Saturn, where its rings tell their own story of space weather and the sun's far-reaching influence. Could Saturn's rings, those stunning, icy jewels that captivate us all, one day vanish because of space weather? It might seem unthinkable, but the forces unleashed by the sun and cosmic radiation are slowly altering this iconic feature of our solar system. Saturn's rings are more than just breathtaking. They're also a kind of cosmic weather forecast, revealing how solar winds and radiation interact with one of the most magnificent structures in space. So, what makes Saturn's rings shimmer? And how is space weather rewriting their story over time? Saturn's rings are composed of countless icy particles, ranging from tiny grains to chunks the size of boulders. Their shimmering appearance comes from their ability to reflect sunlight, creating a dazzling spectacle visible even from Earth. But beneath this beauty lies a battle between the sun's solar wind, cosmic radiation, and Saturn's magnetic field. Solar particles and radiation interact with the icy particles, stripping electrons and charging them. This creates an ever-changing dynamic where the sun's influence subtly alters the composition and structure of the rings over time. Saturn's magnetic field, however, plays the role of protector and sculptor. It helps keep the rings in place, directing charged particles along its field lines and shielding the inner layers of the rings from the full brunt of cosmic forces. Yet, even with this defense, space weather still leaves its mark. Cosmic radiation can gradually darken the ice, while interactions with solar wind accelerate a fascinating process known as ring rain. This ring rain occurs when charged particles from the rings are pulled into Saturn's atmosphere along magnetic field lines, creating a slow but steady loss of material. Astonishingly, it's estimated that Saturn's rings are raining into the planet at a rate of 10,000 kilograms per second, a process that solar interactions are accelerating. Over millions of years, this phenomenon could spell the gradual thinning or even eventual disappearance of the rings we know today. Despite this, Saturn's rings remain a dynamic and ever-evolving system. They are both a testament to the beauty of the solar system and a reminder of its impermanence. Imagine standing on one of Saturn's moons, watching the sun's influence play out on this celestial masterpiece. What a humbling sight that would be. Let us know in the comments, how would you feel if the rings were to fade away? And don't go anywhere. We're heading next to the icy reaches beyond, where the sun's touch extends even to the Kuiper Belt. Did Mars once look more like Earth before solar storms turned it into a barren wasteland? It's a haunting question, and one that brings us to the red planet's greatest vulnerability: its atmosphere. Unlike Earth, Mars has a weak magnetic field, leaving it defenseless against the relentless onslaught of solar wind and radiation. Over billions of years, this cosmic assault has stripped away much of its atmosphere, transforming a potentially habitable world into the dry, desolate landscape we see today. But what happened to Mars's magnetic field? And could Earth ever face a similar fate? Billions of years ago, Mars likely had a global magnetic field similar to Earth's, created by the motion of molten metals in its core. This magnetic shield would have protected the planet's atmosphere from being eroded by solar wind. However, as Mars cooled, its core solidified, shutting down the dynamo effect that generated its magnetic field. Without this protective barrier, the solar wind began to strip away Mars's atmosphere, molecule by molecule, in a process that continues to this day. The results have been catastrophic. Solar wind, a stream of charged particles from the sun, slams directly into Mars' upper atmosphere, energizing gas molecules and sending them careening into space. NASA's MAVEN spacecraft confirmed that Mars loses about 100 grams of atmosphere to space every second, a slow but unrelenting leak that has profoundly shaped the planet's history. Over time, this loss of atmosphere has robbed Mars of the ability to retain liquid water on its surface, making it a much harsher environment for life as we know it. For Earth, Mars serves as a cautionary tale. While our magnetic field currently protects us from the sun's fury, it's a reminder of what could happen if that field were ever to weaken. Could Earth face a similar fate billions of years from now? It's a sobering thought that underscores the delicate balance of conditions that make our planet habitable. Imagine standing on Mars's surface, watching as the sun's solar wind rips away at the thin, dusty atmosphere, an invisible force that has shaped the planet's destiny. It's a humbling reminder of the sun's power and the fragile nature of planetary environments. Let us know in the comments. What do you think Mars might have looked like before this dramatic transformation? And stay with us, because next we're exploring the icy outer worlds, where even distant Pluto isn't beyond the sun's reach. What secrets is the most distant giant hiding in its chaotic magnetic storms? Neptune, the outermost planet in our solar system, is shrouded in mystery. Among its many enigmas is a magnetic field unlike any other, a field that's tilted, off-center, and flips dramatically every few days. Despite its distance from the Sun, Neptune's magnetic storms reveal a world of intense and bizarre space weather shaped by forces we're only beginning to understand. Unlike Earth, whose magnetic field is closely aligned with its rotational axis and generated near its core, Neptune's magnetic field is wildly tilted, angled about 47 degrees off its axis, and appears to be generated far closer to its surface. Even stranger, the center of Neptune's magnetic field isn't aligned with the planet's center, but instead lies significantly offset. This creates a lopsided magnetosphere that shifts and churns unpredictably as the planet rotates, leading to patterns of space weather unlike anything we see on the inner planets. When solar wind, though weakened by distance, reaches Neptune, it interacts with this unusual magnetosphere in strange and unexpected ways. The constant flipping and shifting of the magnetic field mean that charged particles from the Sun can be trapped, accelerated, or ejected in complex patterns. These interactions produce bursts of energy and auroral displays near Neptune's poles, though these auroras are far less consistent than those on Jupiter or Saturn due to the erratic nature of the magnetic field. Neptune's magnetic oddities could be a result of its internal structure. Unlike Earth or Jupiter, Neptune's magnetic field may be generated in a shell of electrically conductive water and ammonia deep within its mantle, rather than in a core of molten metal. This unusual setup could explain why its magnetosphere behaves so chaotically, flipping and realigning as the planet rotates. Imagine standing on one of Neptune's moons, gazing at the faint blue glow of the planet in the distance, while knowing that deep within its shifting magnetosphere, solar outbursts create chaotic storms unlike anything closer to the Sun. What other secrets does this distant ice giant hold? Let us know your thoughts in the comments below. And stay tuned, because next we'll zoom out even farther to explore how the Sun's reach extends to the very edge of the solar system and beyond. Could the same solar winds that give us the beautiful auroras turn Venus into a fiery death trap? Welcome to Venus, the solar system's ultimate hellscape. Beneath its dense, toxic atmosphere lies a world that feels the full brunt of the Sun's fury. Without a protective magnetic field, Venus endures some of the most extreme space weather phenomena, from massive bow shocks to lightning storms that dwarf anything seen on Earth. It's a chaotic environment shaped by relentless solar wind and the planet's own infernal atmosphere. Unlike Earth, Venus lacks a global magnetic field to shield it from the sun's charged particles. Instead, the solar wind crashes directly into its upper atmosphere, creating a bow shock, a powerful barrier of compressed gas and energy that surrounds the planet like a shock wave. This interaction heats and strips away particles from Venus's atmosphere, contributing to its long-term evolution. But Venus's thick carbon dioxide atmosphere fights back, acting as a kind of buffer that absorbs much of the sun's energy and redistributes it in dramatic ways. One of the most fascinating effects of this interaction is Venus's lightning. The planet boasts the most intense atmospheric lightning in the solar system, fueled by its thick atmosphere and constant solar bombardment. These electrical storms can be seen from space as bursts of light flashing through the planet's dense clouds. They're not just visually stunning, they also reveal how energy from the sun drives extreme weather on Venus, creating conditions unlike anywhere else in the solar system. Could we ever study these storms up close? The intense heat, crushing pressure, and toxic atmosphere of Venus make it one of the most challenging places to explore. But future missions, like NASA's Veritas or the European Space Agency's Envision, aim to unravel more of Venus's mysteries, potentially giving us new insights into how solar weather sculpts this fiery world. Imagine standing beneath Venus's swirling clouds, watching as bolts of lightning illuminate the dense, yellow-tinged sky, a storm driven by the relentless energy of the sun. It's a dramatic reminder of how space weather shapes the solar system's most extreme environments. Let us know in the comments, what do you think we might discover if we could explore Venus's storms up close? And don't go anywhere, because next, we'll venture to the very edges of the sun's influence, where the heliosphere meets interstellar space. Does the sun's influence truly end, or does its reach stretch infinitely into space? Even at the farthest edges of the solar system, the sun's power persists. From the Kuiper Belt's icy bodies to the distant Oort cloud, the sun's solar wind continues to shape the space around it, creating a vast protective bubble called the heliosphere. This bubble, while invisible, is the final frontier of the sun's dominion, a place where space weather meets the interstellar void. But how far does this influence truly extend? And could spacecraft like Voyager 1 or 2 detect the next solar storm from this distant outpost? The sun's solar wind, a stream of charged particles constantly flowing outward, travels billions of kilometers before it begins to weaken. At the edge of the heliosphere lies the heliopause, a boundary where the solar wind collides with and is balanced by the pressures of interstellar space. It's here that the sun's influence fades, but it doesn't vanish entirely. Even at this frontier, the sun's storms can ripple outward, affecting the delicate balance of charged particles and magnetic fields in this region. Voyager 1 and 2, the furthest human-made objects from Earth, have crossed the heliopause and now drift in interstellar space. Yet, they continue to send back valuable data, occasionally detecting shock waves from solar storms that originated millions of kilometers away. These observations reveal just how far-reaching the sun's space weather truly is, and they offer a glimpse into the turbulent interface between the solar system and the galaxy beyond. Beyond the heliopause lies the Kuiper Belt, a region of icy worlds like Pluto and the Oort cloud, a vast shell of comets orbiting far from the sun. Here, the Neptune sun's influence wanes, but its faint pull still holds these distant objects within its gravitational grasp. Solar storms and cosmic radiation interact even here, subtly shaping the composition and behavior of these remote regions. Imagine standing on a comet in the Oort cloud, gazing back at the sun, a distant point of light, yet still powerful enough to define the boundary between the solar system and interstellar space. The Heliosphere, a protective cocoon, shields our solar system from much of the galaxy's harsh radiation, ensuring the stability of the planets within. Let us know in the comments. What do you think lies beyond the heliopause? Could the sun's influence extend even farther than we imagine? Stay tuned as we reflect on the incredible ways the sun shapes not just Earth, but every corner of the solar system in our final thoughts. What would happen if Earth's magnetic field disappeared tomorrow? It's a chilling thought. Without this invisible shield, Earth would be exposed to the full force of the sun's solar wind, just like Mars and Venus, and the consequences would be catastrophic. Our planet's magnetic field is the unsung hero of life as we know it, deflecting charged particles, maintaining our atmosphere, and shielding us from deadly radiation. But how close have we come to losing this protection? And what can we learn from the vulnerabilities of our planetary neighbors? Earth's magnetic field is generated deep within its molten core, where the motion of liquid iron creates a dynamo effect. This field extends far into space, forming the magnetosphere, a bubble-like region that deflects most of the sun's charged particles. Without it, the solar wind would strip away our atmosphere over time, just as it has on Mars, leaving Earth exposed to harmful ultraviolet radiation and cosmic rays. One of the closest calls in modern history was the Carrington event of 1859, a massive solar storm that unleashed a coronal mass ejection directly at Earth. The resulting geomagnetic storm caused telegraph systems to spark and fail, with operators reporting shocks and fires at their stations. If a similar event struck, today it could cripple global communication networks, disable satellites, and cause widespread power grid failures. In 2012, a solar storm of comparable magnitude narrowly missed Earth, reminding us of how vulnerable we remain despite our magnetic shield. By studying our neighbors, we see the stark consequences of a lack of magnetic protection. Mars, with its weak magnetic field, has lost most of its atmosphere to the sun's relentless wind, leaving it cold, dry, and inhospitable. Venus, with no magnetic field at all, suffers under a toxic atmosphere supercharged by solar wind interactions. These planets serve as cautionary tales, showing us what Earth might face without its magnetic defense. Imagine waking up to a world where the auroras aren't just confined to the poles, but rage across the skies globally, signs of a magnetic field in collapse. Without it, life on Earth would be dramatically altered, and survival would depend on artificial solutions to block out solar radiation. It's a stark reminder of the delicate balance that sustains us. Let us know in the comments. Do you think humanity is prepared for the next big solar storm? And what lessons can we take from planets like Mars and Venus? Stay tuned for the final segment, where we reflect on the incredible reach of the sun's power and the wonders of space weather across the solar system. The sun, our life-giving star, is also the architect of chaos, orchestrating a cosmic weather report that spans the entire solar system. From the dazzling auroras of Jupiter to the violent lightning of Venus, from Neptune's shifting magnetosphere to Mars's lost atmosphere, each planet tells a story of how the sun's energy shapes its destiny. By studying these phenomena, we not only deepen our understanding of the sun's immense power, but also learn more about our own fragile place in this cosmic dance. But the question remains, will humanity ever master the sun's unpredictable cosmic storms? Space weather research is just beginning to unravel the mysteries of the Sun's influence. Missions like NASA's Parker Solar Probe, which ventures closer to the Sun than ever before, and the European Space Agency's Solar Orbiter, which studies its polar regions, are paving the way for groundbreaking discoveries. These efforts don't just satisfy our curiosity. They prepare us for the challenges of space exploration. Understanding and predicting solar storms could one day protect astronauts on long journeys to Mars, or even farther into the cosmos. But what if we went beyond survival? Imagine a future where humanity harnesses the Sun's power not just on Earth, but in space. Could we use the immense energy of solar winds to propel spacecraft across interstellar distances? Could the very storms that threaten our technology become a source of limitless power? The possibilities are as vast as the cosmos itself. As we look to the future, we are reminded that our journey begins with understanding. Every aurora, every storm, every flicker of lightning on a distant world teaches us something new about the Sun and the universe it illuminates. And while we may never fully control the Sun's cosmic fury, learning to navigate it could be the key to unlocking humanity's destiny among the stars. Let us know in the comments. How do you envision humanity's relationship with the Sun evolving in the future? Could mastering space weather be the first step to becoming a truly interstellar species? Don't forget to like this video, subscribe for more cosmic insights, and share this journey with others. The Sun's story isn't just about planets, it's about us too. Until next time, keep looking up and wondering what lies beyond.